It is incredibly difficult to count the number of atoms accurately because atoms have a radius of about 0.1 nanometers, which is basically 1 times 10 to the power of minus 10 meters. It's like counting the grains of sand in a sandcastle. So instead, chemists use something called the mole. A mole, often abbreviated as N, is a very large number. Just like a dozen means 12, a mole means 6.02 times 10 to the power of 23. This number is also called Avogadro's constant, and it's abbreviated as Na. So say we have 1 mole of water. That means we have 6.02 times 10 to the power of 23 molecules of water. And there is a neat little equation we can use to navigate between moles, particles, and Avogadro's constant. Moles equals number of particles over Na. For instance, how many moles in 1.98 times 10 to the power of 24 carbon atoms? Well, we do the number of particles, which is 1.98 times 10 to the power of 24, and divide this by Avogadro's constant, and the answer is 3.3 moles. Now that we're done with moles, we can move on to molar mass. Molar mass, also written as M in italics, is basically the mass of 1 mole of a substance. And there's an equation for this too. Moles equals mass over mR. Here's a question. How many moles of aluminium oxide are there in 137.7 grams of Al2O3? The mass is 137.7 grams. I need to divide this by the mR. Aluminium has a relative mass of 27, and there are 2 of them. Oxygen has a mass of 16, and there are 3 of them. And the answer is 1.35 moles. What mass does 2 moles of NaCl have? Get the mR for NaCl, which is 58.5, multiply by 2, because we have 2 moles, and the answer is 117 grams. 35.5 divided by 0.5 gives us an mR of 71, which is probably Cl2, since chlorine has a mass of 35.5. And now let's combine both of these equations. How many atoms are in 12.8 grams of H2O? Calculate the moles first, which is mass divided by mR. So 12.8 divided by 18, and we get 0.71 moles. Multiply this by the Avogadro's constant, which is 6.02 times 10 to the power of 23, and we get 4.28 times 10 to the power of 23. Now this is how many molecules of water we've got, but we're asked to calculate the number of atoms. In water we have 3 atoms, 2 hydrogens and an oxygen, so we need to multiply our answer by 3. So we have 1.28 times 10 to the power of 24 atoms. Mass divided by the relative mass gives us 2.7 moles. Convert into grams, so 200 grams, divide by the mR, which is 78, and we get 2.6 moles. Do the moles multiplied by the Avogadro's constant, and the answer is 2.11 times 10 to the power of 22. 1.5 divided by the mR of CO2 gives us the moles. Multiply this by the Avogadro's constant, and we get 2.05 times 10 to the power of 23. Multiply the moles by the mR, which is 44, and we get 110 grams. Divide the number of molecules by the Avogadro's constant, which gets us 2.5 moles. Multiply this by the mR, which is 18, and we get 45 grams. Divide the number of atoms by the Avogadro's constant, and multiply this by the atomic mass, which is 23, and we get 5 grams. The mR is 180. In 180 we have 6.02 times 10 to the power of 23 molecules, which means in 90 grams we do 90 divided by 180 multiplied by the Avogadro's constant, and we get 3.01 times 10 to the power of 23 molecules. In 360 grams we do 360 divided by 180 multiplied by the Avogadro's constant, and we get 1.204 times 10 to the power of 24. And in 45 grams, divide by 180, multiply by the Avogadro's constant, and we get 1.505 times 10 to the power of 23 molecules. Calculate the number of moles of CH4, so 10 divided by the mR, which is 16, and we get 0.625. We can see that the ratio is 1 to 2, as 1 mole of CH4 reacts with 2 moles of O2. That means 0.625 moles of CH4 will react with 1.25 moles of O2. Multiply this by the atomic mass of O2, which is 32, and we get 40 grams. Calculate the number of moles of pH3, so 102 divided by the MR, which is 34, and we get 3 moles. We can see that the ratio is 1 to 1, as 1 mole of P4 reacts to produce 1 mole of pH3. So the moles of P4 must also be 3. Multiply this by the atomic mass, which is 124, and we get 372 grams. 2 moles of lead nitrate produced 4 moles of nitrogen dioxide, so the ratio is 1 to 2, which means 0.6 moles will produce 1.2 moles of nitrogen dioxide. Multiply this by the MR of nitrogen dioxide, which is 46, and we get 55.2 grams. Pause the video and try these 2 questions. This is what you should have got. First, write down the balanced equation, which is Ca plus Br2, giving us CaBr2. Now calculate the moles of the reactants. Bromine has the least moles. It's the limiting reactant, which means the moles of the product will be equal to it. So we have 0.03 moles of calcium bromide. Multiply this by the Mr, and we get 5.99 grams. Again, write down the balanced equation, which is 2Al plus 3Cl2, giving us 2AlCl3. Calculate the moles of the reactants. We can see that aluminium is the limiting reactant, so the moles of the product is also 0.45 moles, since it's a 1-to-1 ratio. Multiply this by the Mr, which is 133.5, and the answer is 60.1 grams.